Hello everyone, JCE Connect. I welcome you all for this particular lecture. So in previous lecture we have been solved one problem on a specific energy. So we'll continue with some more problems. Let us take one more problem, that is a rectangular channel of 5 meter wide carries a water at a depth of 1.5 meter. If the discharge through the channel is 12 meter cube per second, find the critical depth and critical velocity. In this problem, they are asked you to calculate what is the critical depth and what is the critical velocity. For that particular depth, what is the velocity? So here the channel section is given. This is a rectangular channel section of width b and depth y. The data is given here as width of the channel is given as a 5 meter, depth of flow as a 1.5 meter, and discharge is given. So to find here critical depth in a channel as well as a critical velocity, so we know the formula for critical depth. YC is equal to cube root of q square by g, as well as VC, we know that one, g into YC. So to calculate this critical depth, we need to calculate small q. Small q is what? Discharge per unit width. So that is, we know that critical depth formula as cube root of q square divided by g. Then critical velocity root of g into YC. Then small q represents the discharge per meter width, that can be calculated as q equal to q by b. Then this is small q. Then from this you calculate the critical depth. Corresponding to the critical depth, this will be the critical velocity. Okay, I hope you understood this problem. This is simple, but you have to remember only the formula for critical depth and critical velocity. Take one more problem, that is a specific energy for a rectangular channel of 5 meter wide is to be given as 6 Newton meter per Newton. What would be the maximum possible discharge through the channel? Here specific energy is given, the width of the channel is given, and they are asking for that given specific energy what would be the maximum discharge is possible. So first you write the given data. The data is given here as width of the channel is 5 meter given, specific energy is given 6 Newton meter per Newton. Then minimum, so minimum specific energy equation we are having, that is in terms of critical depth. This you write it 3 by 2 into YC. Then from this you get what is the critical depth in a channel. So we get critical depth in a channel as a 4 meter. Then at this critical depth, velocity at velocity you find it at this critical depth, you find the velocity. Then that velocity is called as a critical velocity, root of g y into c. So we get 6.26 meter. Then for maximum discharge, we have a discharge equation as q equal to a into v. Then a is the area of flow, that is b into yc. Since we are having a critical depth, substitute critical depth only here. Then we are having critical velocity, substitute critical velocity. At critical depth and critical velocity, whatever the discharge we get, that will be the maximum discharge. When you substitute all the data here, we get a discharge as 125.2 meter cube per second. This is also simple. Here the discharge specific energy was given. For that specific energy we have been calculated maximum discharge possible in the channel flow. Let us take one more problem. So that is rectangular channel of 3 meter wide discharges 10 meter cube per second of water. If the specific energy head is 1.75, find the possible depth of flow. So in this problem, a channel section is given and width of the channel is given, discharge is given, a specific energy head is given. The question here is what would be the depth of flow in a channel. So here write all the given data once again. B equal to 3 meter, Q equal to 10 meter cube per second. The specific energy head is 1.75 meter. To find depth of flow in a channel, so we know the formula Q equal to A into V. From that formula we can write the average velocity in a channel, Q by A. Then Q is the discharge that is given, A is the area of flow, that area of flow can be written as B into Y, then 10 divided by 3Y, then we get 3.333 divided by Y. Then the specific energy equation, this is the specific energy equation we are having. So use this specific energy, then substitute the given data as well as the calculated data here. Given data is the specific energy 1.75, then substitute the average velocity here. Then when you substitute here and simplify this equation, you will be getting this equation, this algebraic equation, that is y cube minus 1.75 y square plus 0.566. This equation you get. You can solve this equation by trial and error method. If you solve by trial and error method, you will be getting the depth of flow in a general section as a 1.56 meter. Or else you can use calculator. So in this calculator you can calculate this depth of flow. Just you substitute this equation just by pressing alpha x cube minus 1.75 alpha x square plus 0.566. so just I have feeded the equation here. This one, this equation. Okay. Then shift, then solve. You will be getting answer as 1.56. You will be getting 1.56 meter. Okay. I hope you understood this one. Just to solve this equation, either trial and error method or use calculator and feed the equation and get the answer. Okay. So one more problem, that is the Froude number of a flow in a rectangular channel. The Froude number of a flow in rectangular channel is 0.6. If the depth of flow is 2.2 meter, find the critical depth. Here the Froude number is being given. For that Froude number, if the depth of flow is 2.2 meter, find the critical depth. So given data, Froude number is 0.6 is given and depth of flow is given 2.2 meter. So we know that the Froude number equation is V divided by root of G into Y. Then for this one, substitute the value of Froude number here. 0.6 is equal to V divided by root of 9.81 into 2.2. Then we get here, we get this equation. This we get V equal to 2.788 meter per second. Then the discharge per unit width, that is Q, we get discharge per unit width, Q equal to V into Y. This is discharge per unit width. Discharge per unit width, Q equal to V into Y. Substitute the value of V and Y here. We will be getting 6.134 meter square per second. Then we know that critical depth formula, Yc equal to cube root of Q square by G. So substitute the value in this equation, we get Yc as 1.565 meter. Okay. So here the Froude number was given, depth of flow was given. We have used the Froude number equation. From the Froude number equation, we have calculated velocity of flow. Then from the velocity of flow, we have been calculated discharge per unit width, because the critical depth formula is this one. So in this we need to get q, small q, that is discharge per unit. We have got the discharge per unit width. Then substitute here and you will be getting uh, critical depth. Okay, so please practice these kind of problems. So these problems are very very simple. Only you need to remember the conditions for critical depth, conditions for critical velocity, minimum specific energy, and the types of flows based on the Froude number. That is, if Froude number is equal to 1 critical, greater than 1 supercritical, and less than 1 subcritical. So if you remember these things, you can easily solve any kind of problem in this chapter. Thank you.